If you're building with AI, you know the question. It's the one you just can't escape. It's all over every forum, every developer chat, all over social media.
Right? What's the best model right now? Is it Claude 3.5 Sonnet? Is it GPT 4o? Should I be using Gemini? It feels like it's the most important decision you could possibly make.
But what if I told you that is completely the wrong question to be asking, and that the real answer to building better AI agents is hiding in plain sight? So today we're going to explore why focusing on the model itself is pretty much a trap, and where the real engineering work actually lives. See, the problem isn't about raw intelligence. It's about something else entirely.
So what's really fascinating is this recent study that came out with a new benchmark called Epic's Agent. Now, unlike your typical coding puzzles or multiple choice questions, this benchmark tests models on actual complex professional work. You know, the kind of tasks that might take a real-life consultant or an analyst hours to get done.
And this right here just brilliantly shows the disconnect. I mean, these are the same models that score over 90% on those benchmarks that everyone argues about online. But when you throw these real-world tasks at them, the best one only succeeded 24% of the time. 1 in 4. So what is going on here?
Well, the researchers, they dug into why these agents were failing. And the answer wasn't that the models are dumb. Not at all. They had the knowledge. They could reason through the problem. The failures were almost entirely about execution and orchestration. The agents would get lost, they'd loop back on failed attempts, or they'd just forget their original goal. The model wasn't the bottleneck.
So the crucial point is this. It's everything around the model that's breaking down. And there's a term for this that I think is going to define the next few years of AI development: harness engineering.
An agent's harness is all the infrastructure that supports the model. Think of it like this. What can the model see? What tools does it have? How does it keep track of its own progress over a long session? And critically, how does it recover when things go wrong? That whole setup, that's the harness.
And this isn't just some niche idea. The biggest names in AI are all saying the same thing. OpenAI published a whole post on harness engineering. Anthropic released a guide to building effective harnesses. And the team at Manish, the AI startup that Meta just acquired, they said their biggest lessons came from rebuilding their agent framework 5 times in 6 months. Everyone is focused on the harness, not just the model.
Now, this is where it gets truly surprising, because the answer runs completely counter to our instincts as engineers. When it comes to building a harness, it turns out that simpler is often much, much better. Just take this story from Vercel. They had a text-to-SQL agent, and they built it the way most of us would, with tons of specialized tools. One for understanding the database schema, another for writing queries, another for validating the results. It worked okay about 80% of the time. Then they tried something radical. They ripped out 80% of the tools and just gave the agent a basic bash terminal and standard command line tools. The results were, they were staggering.
The results? First, the accuracy shot up from 80% to a perfect 100%.
On top of that, the simpler agent was 3.5 times faster. And it managed all of this using 40% fewer tokens. Just let that sink in for a second. It was more accurate, faster, and cheaper, all because they radically simplified the harness. The engineer who built it said something that just completely flips the script. As models get smarter and context windows get larger, maybe the best agent architecture is almost no architecture at all. Our instinct to add more structure was actually getting in the way. And this wasn't an isolated case. Remember Manish, the company acquired by Meta? They had the exact same realization. Their biggest performance gains didn't come from adding new features, but from removing them, ripping out complex retrieval, killing fancy routing logic, and just making everything simpler. This practical experience actually points to a fundamental principle in the history of AI research, something every developer in this space really needs to understand.
It's known as the bitter lesson, an idea from Richard Sutton, one of the pioneers of reinforcement learning. The lesson is simple. Over the long run, general methods that just scale with more computation will always beat approaches that rely on complex, hand-engineered human knowledge. We keep trying to be clever, but letting the machine learn on its own with more power just works better.
So the crucial point for us is this. As the core AI models get smarter and more powerful, your harness, the structure around them, should get simpler, not more complex. If you find yourself adding more custom logic and pipelines with every new model upgrade, you are fighting against the current.
Okay, so what does this mean for you right now, today? How do we put this into practice? Here's a simple 3-step action plan to start building better harnesses.
First, try the Vercel experiment. Take your agent, strip it down to the basics, like a simple bash terminal and file access, and see what happens. The model is probably smarter than the complex pipeline you built for it. Second, use a progress file. Have the agent write its to-do list and key findings to a file. This gives it an external memory so it doesn't get lost. And finally, look into standardized protocols like MCP and skills. They are basically common languages that let your model use external tools without you having to hard code every single integration.
The big takeaway from all this is that the exact same model behaves in completely different ways depending on the harness you wrap around it. So, the next time you're debating which model to use, remember that choosing and building the right harness is where the real wins are.
And that leaves us with one final thought. The next time your AI agent gets stuck, gets confused, or starts spiraling, ask yourself this. Is it really the model's fault, or is it the harness you built around it?